Wednesday, a mixed review. Thursday, our first Unit 2 quiz, covering topics 2.1 to 2.3. And we'll wrap up our week with congruent figures on Friday. Next week, we'll begin Monday and Tuesday with dilations. Wednesday, similar figures. Thursday, perimeters and the area of similar figures. Friday, we'll wrap up the week with a mixed review. Rotations day 2. Pause the video, take a moment to sketch a coordinate plane and identify the difference between clockwise and counterclockwise. Today we will focus on, you will see clockwise and counterclockwise written this way. Clockwise as simply CW, counterclockwise as CCW. Reminder from yesterday that when we look at the rotations, when we see a 90-degree rotation, remember that that is simply telling us it is one quadrant away. You don't need to copy this, but if you have a figure that is in quadrant 2, remember 90 degrees can go either way. I can go 90 degrees clockwise or 90 degrees counterclockwise. It is one quadrant away. If I'm going 180 degrees and I start in quadrant 2, regardless of clockwise or counterclockwise, I'm going to end up in quadrant 4. 270, a 270-degree rotation. Clockwise, we'll go 1, 2, 3 to quadrant 4. And a 270-degree rotation clockwise would take me from quadrant 2 to quadrant 3, 4, back to 1. Super important to make sure that we understand the difference between clockwise and counterclockwise and how many quadrants away the degrees of rotation take us. So given this example, the vertices of a trapezoid are W at negative 4, 2, X, negative 3, 4, Y, negative 1, 4, and Z, negative 1, 2. Rotate the trapezoid 180 degrees about the origin. Remember, when we have a 180-degree rotation, from the notes on yesterday, 180 degrees does not matter. There is no such thing as 180-degree clockwise or counterclockwise because it's always going to be 2 quadrants away. So if we look at coordinates, W, X, Y, and Z. Negative, positive for all 4 points. If we sketch a quick coordinate plane, quadrant 1 is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. So all of my coordinates are negative, positive, which means I'm starting in quadrant 2. If I start in quadrant 2 and have a 180-degree rotation, I'm going to end up in quadrant 4. So quadrant 2 to quadrant 4, 180-degree rotation. X and Y don't switch. So my X and Y values stay the same. I ignore positive and negative initially. So W prime, for example, should be, if I start with -4, 2, 4 and 2 stay the same. In quadrant 4, all of the coordinate points in quadrant 4 are positive, negative. So here, my 2 should be negative. So let's walk through each of the coordinate points and see if we're on track, if looking at it in that light works. So it says a point XY is rotated 180 degrees about the origin, results in an image with coordinates opposite X, opposite Y, opposite X, opposite Y. So we said that -4, 2 should be 4, -2. Opposite X says opposite of -4 is +4. Opposite of +2 should be -2. Opposite of -3, +4 should be +3, -4. +3, -4. Special note, when we rotate or we have any type of transformation, W prime tells me that we have a transformation. Prime is the designation for a transformation. W and X, these values are my pre-image. When I see values or variables that represent vertices, this tells me that these letters represent the vertices of the image, which is after transformation. Pre-image before transformation, image after transformation. In this instance, we're talking about a rotation. So again, Y to Y prime should be 1, -4. Z to Z prime should be 1, -2. The coordinates of the image are, and we list each vertice in terms of prime. W prime, X prime, Y prime, and Z prime with the corresponding points. And again, we map W to W prime, X to X prime, Y to Y prime, Z to Z prime. 180-degree rotation, again, went from quadrant 2 to quadrant 4. And this was done without even plotting points on the coordinate plane. Example 2. The vertices of a trapezoid are W, -4, 2, X, -3, 4, Y, -1, 4, and Z, -1, 2. Rotate the trapezoid 90 degrees counterclockwise. 90 degrees counterclockwise about the origin. What are the coordinates of the image? And so when we look at the rule for a 90-degree rotation about the origin, counterclockwise 90 degrees is the same as a clockwise rotation of 270. The rules match. X and Y switch, and it will take on the coordinates of the new quadrant. So again, we know that -4, 2, -3, 4, negative, positive. If we draw a quick sketch, positive, positive, negative, positive, negative, negative, positive, negative. If we start in quadrant 2 and we go 90 degrees counterclockwise, we're going from quadrant 2 to quadrant 3. Quadrant 2 to quadrant 3. If we do a 90-degree rotation counterclockwise, 2 to 3, my X and Y values switch, and I should have both negative points. So again, we'll start with W and look at W prime. X value, comma, Y. So I switch 2 and 4. If I'm going from 2 to quadrant 3, W prime should be negative, negative. Negative 2, comma, negative 4. Let's see if that rule worked. So again, opposite of Y, my Y value was positive. When I switched the location, positive 2 became the opposite and became negative 2. For X, X prime should be negative 4, negative 3. Y prime, switch places, both negative, negative 4, negative 1. Z prime, switch places, 2 and 1 switch, and I end up with negative 2, negative 1. So the coordinates after the 90-degree rotation should be as follows. Again, the values went from quadrant 2 to quadrant 3. All of the coordinate points match what we know the coordinate should be in quadrant 3, which is negative, negative. 90-degree rotation, and each of the points map appropriately. The vertices of a trapezoid are W, 2, negative 4, 4, negative 3, 4, negative 1, 2, negative 1. So the vertices of the trapezoid should tell us that these values rest in quadrant 4. Positive, negative are values that are in quadrant 4. 270-degree rotation, 3 quadrants away, clockwise. 270 clockwise. So a 270-degree rotation clockwise is the same as, again, a 90-degree rotation counterclockwise. So if I'm going 270 degrees clockwise, I'm going 3 quadrants away. Clockwise goes right. So if I start at 4 and I go clockwise, I'm going from quadrant 4 to quadrant 1. 90, 180, 270 degrees. The values in quadrant 1 are both positive. We also see again that Y and X switch. Y and X switch, and it's the opposite of what the Y value started as. Doesn't matter the coordinate if we started, and we'll start at W because that's the one that will be revealed first. W to W prime is 2, negative 4. So 4, comma, 2. The values in quadrant 1 are both positive. So 4, 2 is the answer. And let's check out the reveal. 270 degrees clockwise, 3 quadrants away, 4 to 1. 2, negative 4 becomes 4, 2. X to X prime becomes 3, 4. Y to Y prime becomes 1, 4. Z to Z prime becomes 1, 2. So the coordinates are listed and the graphical representation of the coordinate points. Again, the rotation is 270 degrees, which is the same as a 90-degree rotation counterclockwise. This is 270 degrees clockwise. Please don't forget, today we have tutoring from 2:30 to 3:30. For those that are taking the test, we will log you in and I will monitor your Chromebooks and DyNo. Those that need additional assistance with Unit 2 topics, you will remain in the chat and I will provide additional assistance. Don't forget to complete the Get Started and the Homework 2.3b, which will be due tomorrow.